Hello, this is Mr. Stansbury. I'm going to take you through the 14L assignment. Okay, so let's start with number 1. If probability of R equals 0.4, probability of S is 0.5, and probability of R union S is 0.7, are R and S independent events. All right, so we know that they are independent events if A intersect B is the same as the probability of A times the probability of B. Okay? So let's do this first here. We need to figure out what A intersect B is according to this formula. And these two formulas are going to be really handy throughout this section, or at least for the first 3 problems here. So let's do this. Let's see if we can figure out what A intersect B is first by plugging the other 3 pieces that we know into this. So probability of A union B, or R union S in this case, is 0.7. So we have 0.7 equals probability of A, let's just call that R, is 0.4, and the probability of S is 0.5. And then we'll have to figure out what the probability of R, intersect S is. Okay, so we've got 0.7 equals 0.9 minus probability of R intersect S. So let's subtract 0.9 from both sides, and we get negative 0.2 equals negative the opposite of the probability of R intersect S. So the probability of R intersect S is going to have to equal 0.2. Just get rid of the negatives on both sides. Okay? So we now know what this part is here. So if that's the same as multiplying the probability of A times the probability of B, then we're in business. So let's figure that out. Probability of A times the probability of B. So A, or in this case R, so let's turn those into R's. Ugh, that looks awful. Let's just go back. Probability of R times the probability of S. So probability of R is 0.4. Probability of S is 0.5. When you multiply 0.4 times 0.5, you get 0.20, and those equal each other. So are they independent events? Yes, they are, because these two numbers match, right? So the A intersect B equals A times B, and then we figured out what A intersect R intersect S was on that. So it's 0.2 equals 0.2, so we're good. Okay? A little confusing, but we'll get that all. Number 2. If the probability of A is 2/5, probability of B is 1/3, and probability of A union B is 1/2, find this. Okay, so this formula here is going to come in really handy to figure that out. This is going to be helpful throughout. So let's see, we got probability. This is what we're looking for. So A union B we already know is 1/2. Okay, probability of A is 2/5. Probability of B is 1/3. Oops. And then that's going to be minus the probability of A intersect B. So we'll just figure out what this here equals. Okay, so let's turn that on, and we've got 2/5 plus 1/3 equals that, and let's see, I'm going to do math, enter, and that's 11/15. So we have 1/2 equals 11/15 minus probability of A intersect B. Okay, so now we're going to want to subtract 11/15 from both sides, right? And we get a negative probability of A intersect B equals, whoa, wrong button, that one. Okay, so we have 1/2 minus 11 15ths. Gives us negative 0.2333. Again, we turn that into a fraction and make it a little bit nicer for us, and that's negative 7/30ths. So we can simply just switch the signs on both of those. So we got probability of A intersect B is 7/30ths. Okay, so that, oops, sorry, way back up here, that is A, which is A intersect B is 7/30ths. Now, here's what I think is going to be hopefully helpful. I'm going to draw a Venn diagram that includes all this information that we have now. Okay, so here's A, here's B. We just figured out that A intersect B is 7/30ths. So we know that this is 7/30ths. Okay. We know that the probability of A, this whole thing is 2/5. So to figure out what just this part is here, we're going to have to do our let's do this, clear 2/5 minus 7/30ths. And do math, enter, leaves us at this here is 1/6. Okay. And then B is 1/3 minus that 7/30ths also. So we've got 1/3 minus 7/30ths. Leaves us at 0.1, which is 1/10. Right? So now we know all three of those pieces there. Okay, and so we figured out A already, so let's see, part B would then be probability of B, and remember this here stands for given that A has already happened. So we're A, all of A, that's going to be your denominator, which we actually already know A is 2/5, so our denominator is 2/5. So what is the probability that A happened? Is that it? No, probability that B happens, given that A is the only thing we're looking at. So A is all we're looking at, and the probability of the B portion that's overlapping in A is the 7/30ths. So it's going to be 7/30ths over 2/5, which I know starts to get confusing, but that's why I think that the Venn diagram will help, because this is all of A, which we know is 2/5. That's all you're choosing from, and then the part that we want is the 7/30ths. So that's why it's 7/30ths over 2/5. So 7/30ths equals, and let's divide that by parentheses, 2/5. Gives us that. And we do math, enter, and we get 7/12. Okay, for number 2, part B. All right. Probability of A given B. So now the given B, that's this is the only piece that we're looking at. So B was 1/3. So again here, this B is the 1/3, so that's the denominator. And we want to know what's the probability that A happened, so that's the overlap piece, so that's the 7/30ths. So 7/30ths. What's the probability that this A has occurred given that B has already happened? So B is the only thing we're looking from. We want the A portion of that, which is 7/30ths. Okay, so we do. We could just do this. Let's do this. Parentheses 7 divided by 30. Close, divided by parentheses 1 divided by 3. And then we know that we'll have 7/30ths divided by 1/3, which gives us 0.7, which is 7/10 if we write it as a fraction. Okay? And then it says, it asks, are A and B independent events? So they're only independent events if this A intersect B, which is 7/30ths, does that equal the probability of A times the probability of B? So they didn't even give us a letter for that. I'm going to just call that D, so we know where it's at here. So D. So our A and B independent events, we know that A intersect B was our answer to part A. So does 7/30 equal probability of A times the probability of B? So does that equal 2/5 times 1/3? Is this true? So let's calculate it out. So we've got 2 divided by 5 times 1 divided by 3. Math, inner, and that gives us 2/15. Does 2/15 equal 7/30? No, it does not. So they are not independent events. Okay. Moving along, we got number 3. Probability of X is 0.5, probability of Y is 0.7, and X and Y are independent events. So we already know that they're independent events, so we don't really need this. Determine the probability of the occurrence of both X and Y. So I take that back. We are going to want to use this for A here, because A is asking what's the probability of the occurrence of both X and Y. So that's what this means. That's X and Y, or A and B, which in this case is going to be X and Y, because we can really just put in X there, Y there, X, Y, all these. We're just going to change to X's and Y's for this problem here, right? So X and Y is just going to equal the probability of X times the probability of Y. So probability of X, we got 0.5 times 0.7. If we multiply that together, we get 0.35. So that's what the probability of both X and Y is going to be. Okay. Probability of X or Y, so that's going to be, if we're looking really at a Venn diagram here, ooh, that's terrible. X and Y is just this middle section in here, right? But X or Y is going to be all 3 of these sections together. So we got to figure out what that's going to be. So that's where this formula down here is going to come in handy, because we've got X union Y. This is X or Y, right? So we're just going to need to do the probability of X, which is 0.5, times the probability of Y, which is 0.7, and then we're going to subtract the probability of X intersect Y, okay, which is what we just figured out right here is 0.35. Oh, sorry, never mind. Sorry, I forgot that this is, I'm got a little ahead of myself, so we have to add these two together. We're not multiplying these two together, and then we do subtract our A and Y, the A intersect Y, which is our 0.35 right here. Okay, so if we do this here, 0.5 plus 0.7 is 1.2 minus 0.35 gives us 0.85. Okay, so that's the probability that X or Y is going to happen. Okay, so for part C, it says neither X or Y. So if the probability of either X or Y is going to happen is 0.85, that means the complement of that is going to be neither X or Y. So we would just do 1 minus 0.85 means the other 15%. If 85% chance that X or Y is going to happen, there's a 15% chance that neither X or Y happens. Okay? E. We've got, oh, I probably should do D before E. A hard time with my alphabet. What's the probability of X happening but not Y happening? Okay. So if we think about this like with a Venn diagram, I like to do that. It just makes it a little bit easier for me. So here's, let's say we got X and Y. So we're trying to figure out probability of X happening but not Y happening. So X happening but not Y is, so the probability of X happening is 0.5, right? So that's going to be the probability of x minus the probability of x and y happening, right? So minus the probability of x and y happening. So probability of x from up here is 0.5, so we got 0.5 minus the probability of x intersect y, which we figured out is this one right here, right? That's minus 0.35 gives us 0.15. So there's a 15% chance of x happening but not y. Okay? And then for E, probability of x happening given that y occurs. So we know that y happens. Okay, so y is going to be given that, oops, that's not a good underline. Okay, so given that y occurs is that 0.7 right there. Okay, so that's the given part. So what's the probability that the x happens? So again, here's the given that y happened, what's the probability that x is going to happen? So that's that intersection piece there. So that's the 0.35. 0.35. So if you take 0.35 and you divide it by 7, 0.35 is exactly half of 7, so that's 0.5 or just 1/2. Okay? Okay. Let's take a look at 4. The probability that A, B, and C can solve a particular problem is 3/5, 2/3, and 1/2 respectively. If they all try, determine the probability that the group solves the problem. So, there's like just a real subtle, nice thing about this that will make this a much simpler problem. So you're trying to figure out what's the probability that any one of those is going to solve it. An easier route to figure this problem out is to figure out what's the probability of not solving it, right? And then we can just take 1 and subtract that amount, and that will be the probability of them being, at least one of them being able to solve it. Because if we were to figure this out separately, we'd have to figure out what's the probability of A solving it and not B and C, and then you'd have to add what's the probability of B solving it but not A or C, and what's the probability of C solving it but not A or B, what's the probability of A and B but not C. But anyway, you end up getting all these different things you got to add together. But the much nicer way is just figuring out what's the probability that none of them will solve it, and then take the complement of that. So let's do that. 1 minus the probability of not solving. So if the first person's probability that person A solves it is 3/5, that means the probability that they won't solve it is 2/5, right? So it's just the complement of all of these, and the probability of the second person solving it is 2/3, so the probability of them not solving it is 1/3, and the probability of the last person solving is 1/2, so the complement of that is 1/2. So we'll just figure out what this is, right? So let's do this. So we got, well, really, we can just do 2 times 1 times 1 is 2. 5 times 3 times 2, 15. That's what, 2/30ths? So that's 1 minus 1/15. So really, that's 15/15 minus 15/15 minus 1/15 gives us 14/15. So there's a 14 out of 15 probability that that one of them is going to end up solving it, or at least, or like a group of them being able to solve it. Okay, the group as a whole. All right. 5. Determine the probability of getting at least 1/6 when an ordinary die is rolled 3 times. Okay, same thing as the problem that we just did. At least 1/6. The easier way to figure that out is to figure out, take 1 minus the probability of no 6s rolled, right? So that's just going to simply be 1 minus the probability of not rolling a 6 on the, since we're rolling 3 times, the probability of not rolling a 6 on the first one is 5 out of 6, right? Probability of not rolling a 6 on the second one is 5 out of 6, because they're all independent events. And the probability of rolling the third 6 is still 5 out of 6. So that's going to be 1 minus 5 times 5 is 25 times 5 is another, let's see, 125. And 6 times 6 times 6 is, I believe, 216. So then we're just going to do 1 minus 125 over 216. 125 divided by 216. So that gives us 42%. Okay, so let's go with that. Equals 0.42, let's go 421. Or 42.1%. Let's see if this will turn it into a fraction for us. Math, enter. Or 91 out of 216. Any one of those answers would be just fine. Okay? Okay, last one. A, B, and C have 10, 20, and 30% chance of independently solving certain math problems. If they all try independently of one another, what's the probability that this group will solve the problem? Similar to the previous two, if we figure out the complement of them, not any of them solving it, that will be what the probability is that this group will solve it, right? So we just want to do 1 minus the probability of nobody solving, right? So that's going to be 1 minus probability of the first person solving it is 10%, so the probability they won't solve it is 0.9, right? And then the probability of, not plus, but multiply, the probability of the first person and the second person not solving it, so second person is 20%, so that's going to be, complement of that is 0.8, okay? And then multiply that by the probability of the third person not solving it. So if they solve it 30% of the time, that means the other 70% of the time they don't solve it. So we'll do 1 minus whatever that is. And we get 0.9 times 0.8 times 0.7 gives us 0.504. 0.504. Oh, I keep pushing the wrong button, sorry. Minus 1 gives us that the probability, and again I just got to ditch the negative because I did this backwards, so probability is 0.496 or 49.6%, or let's see if it'll turn into a decimal a fraction for us. 62 out of 125. Any one of these is great. Okay? Alright, that's all there is for this one. If you have any further questions, please ask in class. Thanks so much.